Reimagining the electric car battery with quantum computing. I'm Tonya Hall, and joining me is Dr. Jeff Welser, Vice President, IBM Research Almaden, Pacific Rim Labs, and Exploratory Science. Welcome, Jeff.
Thanks for having me.
So, what are the research areas that you and your teams focus on at IBM Research? What are you working on right now?
So a lot of our research focuses on really advancing the future of computing, whether that's continuing to do the hardware and software for standard high performance computers or in the AI space or in the quantum world. We also spend time looking at ways that science can be applied at exploratory levels to improve society and the world.
IBM Q and Daimler just announced a research breakthrough that could help solve one of the technological barriers facing electric vehicles today. So tell us about that.
Yeah, this is part of the work we do also for impact science in general, ways that we can actually impact the world with our science. So we've been working with Daimler for a while on ways to improve battery chemistry. Obviously, lithium-ion batteries are sort of the standard right now in automobiles, but are there ways we could have higher energy density, higher capability, better charging times in those batteries, maybe make them less expensive? So one of the chemistries we've been looking at is lithium sulfur. Together. And we've been now working on that in a number of ways, but one of them is actually using our quantum systems to prove out the capability for quantum computers to actually help us in analyzing quantum chemistry problems.
So, what advantages do quantum computers offer when simulating subatomic particle interactions within the molecule?
But the reason that quantum computers can be quite useful for that are that they themselves are quantum. So when you're trying to do the simulations of an atom or a bond that's being formed, you're dealing with electrons and orbitals which have quantum properties. So they rapidly end up creating a lot of different types of states you need to actually test. So on normal classical computers, you can probably only do a molecule up to about 22 electrons or so before you really can't simulate it exactly anymore. So of course, you use approximations and things instead. With a quantum system, the hope is you could actually go simulate very, very large molecules in the future when the systems themselves get big enough. Now, of course, today our quantum systems are somewhat small, so we're starting off small. For the lithium sulfur batteries, for example, we use the systems to try to simulate both the ground state as well as the dipole moments of some of the most important products that come during those reactions: lithium hydride, hydrogen sulfide, as well as lithium sulfur itself, which of course is the desired product. And for the first time, we actually did use just a 4-qubit quantum system to simulate a lithium hydride dipole moment, which was kind of a cool breakthrough for us.
Explain the relationship between IBM Research and Daimler on this project.
Yeah, so we're partnering with them. We do this with a lot of our partners, both in quantum computing and other places. So we like to partner with companies that have real world problems. So Daimler, of course, is very interested in trying to improve battery technology for their cars. And where we think we have technology, they can go and help those problems. But by working with real subject matter experts who really understand their business, we feel that really helps advance the research much faster.
Dr. Jeff Welser, Vice President, IBM Research Almaden, Pacific Rim Labs, and Exploratory Science. If somebody wants to connect with you, what's the best way they can do that, Jeff?
Yeah, probably on Twitter. Follow us at IBM Research or at Jeff Welser.
There you go. And you can find more of my interviews right here or at tonyahall.net. Thanks for watching.